propose what we think is a quite natural way of introducing non-comparability, and this is in the form of thresholds. So this criterion, of course, is the same as saying this difference should be non-negative. And we propose to introduce, instead of 0, a threshold. And the threshold can depend on the difference in population size. And there's a good reason why it can, because it will actually come out of the properties that we use to characterize our class of quasi-order rings. So this will look, I will write down the generalization now. It may look a bit, it may look overly complex. And it's not because I want to inflict pain on you or anything, but this is just the way the class works out. And you will see the more once I write down the properties, you'll see where it's coming from. Because one of the things we do not want to give up is transitivity, and to get this across comparisons of different dimensions, you have to be very careful. So for starters, there's two things we have to specify. And initially, for the first, we thought, well, do we want a weak inequality or a strict inequality? To have to reach a threshold or surpass it. And first we thought, well, we could probably do it either way, and not so. Not so. Because there are other possibilities. But because there are other possibilities, I just use a symbol, a little triangle, which will stand for a comparison that's either a weak inequality or a strong inequality, or strict inequality. So this may depend on the difference in population size. Furthermore, we don't want a 0 here, but we want some notion of a threshold that again may depend on the difference in population size. And we'll see in a moment why it has to be that way. So we can represent this in terms of a threshold function. That's basically a sequence. We could write it as function too, whatever sequence is just doesn't make any difference. That's a threshold function, and basically the restrictions here is first of all this little triangle, delta k, or triangle k, is either a weak or a strict inequality for all possible difference happens every year. So far I'm still reasonably enough shape that I can absorb it. If not, I'll sue you all. And then we have a threshold function h, which assigns to all possible differences in population size, 0 included, because these could be the same. A non-negative number. All right. Now, this is not all. We have to impose a few restrictions on that. So this, basically, the class of quasi-orderings that we consider, we call them threshold critical level utilitarianism, is such that, first of all, alpha has to be a real number, a critical level. Moreover, we want the threshold inequality at 0 to be a weak inequality, and the value of the threshold function at 0 to be 0, because that gets us back to full comparability in the case of same population. By the way, we get this as a result from our axioms. Furthermore, everything else we do is basically to make sure we don't mess around with transitivity. So first of all, we know we have to satisfy the following restriction. Suppose you have a comparison that involves n and m people, and you have a comparison that involves m and l people. Well, in order to make sure that we don't violate transitivity, we have to make sure that this is greater than or equal to what happens if you have n minus l. This has to be true for all possible population sizes n and L. And essentially a consequence of this is that H has to be sub-additive. Right? But we need it for transitivity. But that's not all, and that's what we didn't figure out at first. We also need the following. Suppose you have a threshold inequality involving n minus m people in the comparison, and the threshold inequality involving m minus l people, that is the inequality. That means at the boundary cases, you have to worry about when you combine the two, what happens with the n minus L people. So if this is the case, then one of two things has to happen. Either the threshold inequality for n minus L is also weak inequality, or another way of getting around the transitivity problem is that this inequality is satisfied with a strict inequality. Took us a while to figure it out, but once we did figure it out, it kind of makes sense.